Assalamualaikum and good morning. So for today's video, I would like to show you about Minitab. So please refer to Minitab workbook on page 138. So Minitab is one of the statistical software used to analyze data. So many other software available. However, in your final, you should be able to interpret the statistical analysis output from Minitab. Okay, so Minitab is a statistical package developed at the Pennsylvania State University, and this is designed essentially for the Six Sigma professional. Six Sigma is basically related to quality control or quality assurance. First, I will open the Minitab. Alright. Okay, so when you open Minitab, you will typically see something that looks like this. Okay, so the top window is called the session window, and the bottom window is the worksheet window. Alright, and then when you ask Minitab to plot something, another window will appear that is called graphic window. Okay, so from chapter 2, confidence interval, here we use Z-test and T-test. Z-test when population standard deviation known and sample size is large, and T-test is used when population standard deviation unknown and sample size is small. Okay, first one, confidence interval for one population mean. So now I will show how you can key in data and then get the output. Okay, first this one is the following are the weights in decigram of 10 packages of grass seed distributed by Grassy Strendian Berhad. So first we key in the name of the data and then key in the value. Okay, one column downward 7. So here we have 10 sample. Okay, using Minitab, select stat, basic statistic, one sample, T-test. Choose grass seed as the variable. So sample in columns, grass seed. So grass seed, double click. So immediately pop up here, and then click options. So we want 95% confidence interval. So not equal. Click OK, and then OK. So we get the output same as your notes. Right, so now the question is show that the standard error of the mean is 0.218. Alright, so number 1, standard error equals to S per square root of n. So S, standard deviation, 0.69 divided by square root of n. So here we have n equals to 10, so divide by square root of 10. So you will get 0.218 shown. Alright, next, show that the 95% confidence interval for the mean weight distributed by Grassy Strendian Berhad is 45.766 and 46.754. Alright, second one, 95% confidence interval for mean mu. So since this is one sample T-test, so we use T distribution, x bar plus minus T alpha over 2 times S per square root n, the standard error. So alpha here 0.05, so alpha over 2 0.025, and then degrees of freedom n minus 1 9, so T 0.0259 equals to, so refer to table. Okay, T 0.0259, so 2.262. So substitute, so x bar is mean, so this one is x bar, this one S, this one standard error of mean. Alright, so 62.26 plus minus 2.262 times standard error 0.218. So plus minus shown. Right, interpret the interval obtained. So number 3, we are 95% confident that the mean weight of all such packages of grass seed distributed by Grassi Sendirian Berhad is lies between 45.766 and 46.764 decigram. Okay, the last one. Based on the 95% confidence interval for the mean weight, can you conclude that a package of grass seed will get a weight of 47? So, based on the 95% confidence interval, we cannot conclude that a package of grass seed will get a weight of 47. Why? So this one, exit 47 is exit confidence interval limit. That's why. Okay, next, the second question. In a continuing study of the amount of MBA students are spending each term on textbooks, data were collected on n samples equals to 81 students. In previous studies, the population standard deviation has been sigma equals to 24 in USD. So here, the population standard deviation is known. So here the Minitab output show that the 99% confidence interval estimate of the population mean is 281 to 295. So this one Z test. So use Z. Alright, so the first one, 99% confidence interval for mean equals to X bar plus minus Z alpha over 2 sigma per square root of n. Right. So here alpha equals to 0.01. Alpha over 2 equals to 0.005. Right, so Z alpha 0.005 is 2.5758. So X bar mean 288 plus minus 2.5758. Standard error mean sigma per square root n. So 2.6667. So equals to 288 plus minus 6.869 equals to 281.13 and 294.87. So equal to 281.295 shown. The second one, interpret the result. We are 99% confident that the population mean lies between 281 and 295. The third one, standard error equals to sigma per square root of n. So sigma 24 over square root of n 81. So we get 2.6667 shown. Next is confidence interval for two population means. So as you know, there are two cases. Case 1, population standard deviation or variance known. So we use Z. Case 2, population standard deviation unknown. So there are two assumptions. The first one is equal variance and not equal variance. So how to know whether the output is for case 1 or case 2? either equal variance or not equal variance. So this one first, here is t-test. Therefore we know it is for the case 2. And then to decide whether equal variance or not equal variance, so remember equal variance we use pool variance or pool standard deviation. So from this output, here we have pool standard deviation. So we know is this, in this case it is equal variance, right? So the first one show that the pool standard deviation is 7.5531. This one. So we calculate the pool variance as pool. So the formula is pool standard deviation square root n1 minus 1 as 1 square plus n2 minus 1 as 2 square divided by n1 plus n2 minus 2. So we have 38. So this one standard deviation 7.62 square plus 38. So n2 is 39 also. So n2 minus 1, 38. 7.49 squared divided by 39 plus 39 minus 2. And then you calculate, you will get the answer is 7.555. Sure. Alright, next. Show that the 95% confidence interval for the difference in mean number of complaints on a particular brand for the 2 suppliers in Louisiana and Kansas. So 95% confidence interval for difference in mean equals to x bar 1 minus x bar 2. So 50.69 minus 47.29 plus minus t alpha over 2 s pool times 1 over n1 plus 1 over n2 square root. Alpha equals to 0.05. Then alpha over 2, 0.025. Degrees of freedom, n1 plus n2 minus 2. So 78 minus 2, 76. So find the value of t 0.025, 76 from the table. Right, 0.025, 76. So we don't have 76 value. So we take before 76. So 60. So the value is equals to 2. Equals to 2. And substitute, calculate 3.43 plus minus. So full variance 1 over 39. 1 over 39 square root. Then calculate. We have minus so we get 0.01 and 6.852. Right. So our answer is slightly different from the 95% confidence interval from the output because our value of t is approximate number. So never mind, it is acceptable. Okay. So lastly, number 3. Based on 95% confidence interval, is there enough evidence to conclude that the mean number of complaints on a particular brand for the 2 suppliers in Louisiana are equal? So mean, okay, so our confidence interval greater than 0. So since both positive, so since the 95% confidence interval does not contain 0, there is not enough evidence to conclude that the mean number of complaints on a particular brand for the 2 suppliers in LA and Kansas are equal. Why? Because both positive. If you get the confidence interval negative and positive, then there is no difference. That means there is difference in mean. Alright, next, second question. So this one, two sample t-test. So T is hospital A, hospital B. Then assume unequal variance. So this one is case 2 using T and then unequal variance. So for unequal variance, no pool variance. Alright. So this one for the equal variance, in the output we'll have pool standard deviation or pool variance. Alright. So you have to recognize the difference between unequal variance and equal variance output. The question is, write down the 95% confidence interval for the difference between ratings for the two hospitals. Interpret its meaning. So number 1, the 95% confidence interval for the difference between ratings for the two hospitals equals to, so from the output 14.221 and 27.779. Alright, interpret its meaning. We are 95% confident that the difference between the mean difference between ratings for the two hospitals is lies between 14.221 and 27.779. Right. And show that the degrees of freedom is 32. Right. The formula is given, degrees of freedom. So the formula S1 square over N1 plus S2 square over N2 and then square over S1 square over N1 square over N1 minus 1 plus S1 square over S2 square over N2 square over N2 minus 1. Right, so substitute the value. So standard deviation 8.183 square over 20 plus 12.431 square over 20 square 8.183 square over 20 square over 19 plus 12.431 square over 20 square over 19. So calculate, you will get 32. Right, last one, number 3. Based on the confidence interval, determine whether there is difference in the patient ratings between hospital A and hospital B. So based on the 95% confidence interval does not contain 0, therefore there is difference. There is enough evidence to conclude that there is difference in the patient's rating between hospital A and hospital B. So that's it. Thank you for watching.